Hello and welcome to the series of videos on microprocessor. My name is Rajakishore, Assistant Professor in Department of ECE, Mari Lakshman Reddy Institute of Technology and Management. I am going to the faculty walks through the fairly detailed program on understanding the 8086 microprocessor. And what I'll cover is a little bit fundamentals of the microprocessor. In general, zoom down very quickly what is processor, architecture of 8086 microprocessor, instruction set, peripheral devices like 8279, 8251 and 8255 and so on. And not only with the peripherals, and we are going to see the 8087 arithmetic coprocessor. What is arithmetic coprocessor and details architecture of those things. And also we are going to be discuss about fundamentals on 8051 microcontroller also. In this course, what I will not cover is the fact figures, things that are fairly simple to understand, that doesn't require any conceptual explanation. Those you will find any book or any website that you're not required going to be touching in this course. And this video what I'm recording is a self-contained video, which means that each video consists or cover a logical trunk of information, or sometimes I may split the video into multiple videos. In fact, the longest one is going to be split into 3 to 4 videos. And each video, again I'm saying each video will consist of a logical piece of information. And let's going to look at the history of microprocessor. So the first microprocessor was really called as a Tomcat, which was developed by the Department of Defense USA. But the first commercially available microprocessor was 4004. This came from the Intel, was a 4-bit processor and contained a grand old 2300 transistors. That is the state of art at the time. And what at the time I'm talking about is the November 15th, 1971, which was the first launched. And today processor have exceeded more than 10 billions of transistors that advanced you have seen in the last 40 years. And the Intel 404 has run at 740 kilohertz, whereas the latest processor, if I am considering as Intel Xeon, which has consist of more than 6 billion transistors. And whereas if you come for the Intel 4040, okay, which run at the speed of 740 kilohertz, whereas the Intel Xeon processor, which is run at the up to 3.2 gigahertz, and the latest processor which we consider as it can also having the more than that speed. And now a real fact, do you know that what is the mobile phone will also works under a 16-bit processor. So if you consider even our mobile phone uses the 64-bit processor in it. And next, if you going to see the first picture of Intel 040404, this is the first 4-bit microprocessor, as I said earlier. And if you remove the golden foil over that, and if you see this is an architecture after removing the golden foil. And even though if I zoomed out with a microscope in after removing the fold, and this will tells the this particular figure tells about the architecture, that is nothing but I'll show you color out of the thing. This particular thing will is the internal architecture, which shows the internal architecture of 404. So inside the view of 404. And now So now we'll come to the end details about what is processor. So what is a processor? So a processor is nothing but a heart of the processor is a central processing unit, where this central process unit consists of registers which are used to store some temporary data, and called unit is a central unit, and arithmetic logic unit which used to be performed in arithmetic logical operations. So all these kinds together called as a CPU, called as a central process unit. And now this central process unit, entire processor of CPU, addition to we have a certain memory unit also. So the registers and so forth, excess of this, it could have a bus interface unit. This is a bus interface unit which used to transmit the data over arithmetic logic unit or a registers in and out of your memory units. All together, the packed, a nice looking package is called as a microprocessor. So if I say microprocessor on its own has no meaning and no need to connect, the input devices like a keyboard, mouse, joystick, and so on. So without these input output devices, we can't say that there is no meaning of a processor. Why? Because it won't work any further with supporting of these additional units like input output units, as I said, that a keyboard, mouse, or joysticks are an output devices. So again, if you come for an various forms of an output device, as typical one called as a monitor, of course a printer will also called as an output devices. So all these comes together become a computing engine. So what the computing engine means, that it going to be perform some particular task. Altogether I can say it is called as a computing engine. So then we'll see how does the processor connect to the external world. So a microprocessor need to be connected to the external world by means of a bus configuration, where the bus configuration consists of an address bus, data bus, and the control bus. So these are the three different buses which are used to interact with outside world, makes our processor to interact with your outside world. Each of these uh, buses is either connected to either memory devices or a various interfacing or an IO ports. Why should I connect to the various input output? Because if I want to interact with the processor, these are the requirement. Not only the memory devices, but also it can able to interact with the interfacing devices or IO ports. So it is not enough. So you have to address the bus's data bus and connect it. You need to have something called as an address decoder. Here it is showing as a, here it is I'm showing an address decoder. This address decoder. Because if I want to interact with an outside world, its memory units are not only the sufficient, but it requires an address decoder also. So how does the processor knows that a keyboard or display is talking to? The address decoder help to that do that. The address decoder takes the address lines from the processor, takes read signals and write signals from the processor, and decode it accordingly, and triggers the various peripheral devices. So this is a main function of your address decoder. So the kinds of language that processor can understand. So as we know that whatever the programming language we are going to be write to interact with our computer is called as a high level language. So really top of the what called as high level languages, and these are called as a C, C++, Java, Python, and so on. And many of you are familiar with these kinds of languages. But this language is not something that the processor understood. What you need to do is the a compiler it, when compile it or interpret it, come down what is called as an assembly level language. Assembly level language is a very processor specific, so which indicates simple words. I can say that if I want to convert any high level language into a assembly level language, we required a compiler or an interpreter which converts our high level language into a mission level assembly level language. So then what will 8086, because as I said that assembly level language is a processor specific, so 8086 has own assembly language. It cannot be understood by the processor other manufacturers, but assembly level language also can't be understood by the processor. So then what we need to do? The assembly language has to be assembled only after assembled by an assembler. So an assembler do you get called as a mission codes or an op codes, and it is a mission codes and op codes that understood by the processor, which I can simply say that an assembler used to convert again your assembly level language into a mission level language so that the processor can understood. And so these are the some of the basic high level languages. As I said that COBOL, Java, and the mission can understand only assembly. So as a simple words, languages that reason is that high level languages are very closer to the English, and it cannot be understood by the human. It can be understood by the human being, whereas the opcodes and just as a series of ones and zeros, a human being finds extremely difficult to handle these series of the strings, zeros and ones. A computer for a microprocessor, it is in a natural state, loves ones and zeros, and that's why we need require these high level languages. So this brings to me the end of my series of section of introduction of the microprocessor, and next section I'm going to be talking about the architecture of 8086, various modes of operation. Till then you read to bit of concepts like microprocessor. I have just spoken the material out and the compare with the processor with the manufacturer designed AMD, and until then happy reading. Thank you very much.